In this video, we're going to look at how we can use a recurrence relation in reverse. So we're given our recurrence relation here, which is linking un plus 1 and un. Okay, so it's the first order ones. They have a difference of 1 in the subscripts. Now we're given the first term in the sequence here. Okay, so we could use that to find the second term and then the third term and then the fourth term and so on. We're also given the 100th term. So based off what we've learned previously, we could use that to find the 101st term and so on. But we're asked to find the 99th term. Now we're not going to want to do that using the first term, because to get to the 99th term, you have to go through the second one, the third one, the fourth one, every single number up till 99. So that's going to take ages. However, what we could do is make use of the 100th term and use the recurrence relation in reverse in order to get back to the 99th term. So if we look in our recurrence relation, our highest subscript is n plus 1, and then we have one subscript that's one smaller than that, which is the n. So therefore the 100 would be going in place of the n plus 1, and then the 99 is going to be going in place of the n. So what I can do is I can substitute my 100th term, so the 265,717, in place of the un plus 1. So I would get 265,717 is equal to, and then we'd have the 3, and then it says un. Well, un is going to be u99, and then we got plus 7. And now we have an equation which we can rearrange to solve for the 99th term. So we could subtract 7. So we get 265,710 is equal to 3u99. And then we can divide by 3. And that is going to give me the final answer to the question. So putting it into the calculator, we get 88,570. Let's have a look at another question. So we got this one here. And if we look at our recurrence relation, our highest subscript is n plus 2, our lowest is n. That is a difference of 2. So this is a second order recurrence relation. So therefore, you'd need 2 terms to generate the next term. Okay, or 2 terms to generate the previous term. So we're given u7 and u6, so consecutive terms. And then we need to use our recurrence relation to find the term before both of them, which is u5. Okay, so the un plus 2, that's our highest subscript, so that should be the 7. And then the n plus 1, which is 1 less, okay, that is going to be the 6. And then therefore the 5 is going to be our un in this case. So now we can try and substitute in. So for our un plus 2, I'm going to put in the 8. For the un plus 1, I'm going to put in the 4. So we'd have 3 times 4. Then plus, and then we've got 7 lots of un, which is going to be u5, which I'm trying to find. And then we got subtract 5, like that. So then we've got ourselves an equation to find this 5th term. So if we simplify, we have 12 there. And then if we simplify the right-hand side, we're going to get 7 plus 7 lots of u5. And then rearranging, subtract 7 to get 1 is equal to 7 lots of u5. And therefore, u5 would be equal to 1/7. So let's have a look at another question. Okay, in this one here, we have the same recurrence relation as before. We've been given the 7th term, which is 8 again. However, this time we've been given the 5th term rather than the 6th term, and that's equal to 4, and we are asked to find the 6th term. So we're being asked to find the term between the 7th one and the 5th one. Now we can still use this recurrence relation to do that because it's a second order one, because the difference between the highest subscript and the lowest one is 2. Therefore, we can have 2 non-consecutive terms providing they have a difference of 2 in the subscript, and use it to find the term between them. So this time, the n plus 2 is going to be the 7. Okay, now the n plus 1, well, that's going to be the 6 that we're trying to find, the 6th term. And then the n in the UN is going to be 5, like that. So let's do our substitution. So we'd have 8 on the left-hand side again. Then we'd have 3 lots of UN plus 1, which is just U6. I don't know what that is. And then we got plus 7 lots of UN, which is U5, which is going to be 4. And then subtract 5. And once again, we've got an equation which we can solve to find U6. So we've got 28 subtract 5, so that's going to be 23. Then we subtract the 23, so we get negative 15 is equal to 3U6. And then dividing by 3, the sixth term would come out as negative 5.